Okay, welcome to the first S2 marathon. The topic for today is hypothesis testing using the binomial distribution or hypothesis testing of the population proportion. I hope you've seen the lecture videos. If you haven't already seen the lecture videos, I would strongly recommend that you go back and see them and then follow this marathon. I'm going to again try to do as many questions as I possibly can and do the rest of them in the next video probably. Okay, it says Jack is a chef. He claims that 90% of his customers, so he's telling you something about P, uh, customers are satisfied with his cooking. Mary suspects that the true percentage is lower than 90%, so this looks like a lower tail test. She asks a random sample of 15, so n is 15. Whether they are satisfied, she then performs a hypothesis test of the null hypothesis P equals to 0.9 against the alternative hypothesis P is less than 0.9, where P is the population proportion of customers who are satisfied. She decides to reject the null hypothesis if fewer than 12 customers are satisfied. So I've told you the rejection region. In the context of this question, explain what is meant by a type 1 error. So type 1 error is basically, if I were to write that in theory, is rejecting H naught when H naught is true. So in this case, if I see the question, H naught is 0.9 and H1 is P is less than 0.9. So I have wrongly concluded, if I'm saying that there's a possibility of a type 1 error, then what I've done is that I've wrongly rejected H naught. So I have concluded that less than 90% customers are satisfied, but that is not true. Okay, that's the simple idea of a type 1 error. It says find the probability of a type 1 error. So a type 1 error is basically probability of the rejection region, or we also call it the true significance level. So probability of the rejection region. The rejection region is fewer than 12, so I'm just going to write x is less than 12, or I could write x is less than or equals to 11. N is 15, P is 0.9, so I get, I can't go on and calculate 11, 12, 13, 14, 15. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's going to be a long calculation. So what I'm going to do is I'm going to subtract 12, 13, 14 and 15 from my sum of probability, which is 1. I'm going to write 1 minus 15c 12, 0.1 power 3, 0.9 power 12, 15c 11, 15c 13, 0.1 power 2, 0.9 power 13, 15c 14, 0.1 power 1 and 0.9 power 14, 15c 15, 0.1 power 15 and 0.9 power 0, 0.1 power 0 and 0.9 power 15. I'm going to put this all on a calculator. If you've seen my videos before, binomial distribution can be done with a calculator and makes calculations a lot easier than you would otherwise find them. So I am going to do that on my calculator. If you haven't, the white ClassWiz calculator, this one, helps you calculate probabilities directly. So make sure that you have this if you're doing that. The S2 exam is going to make your life a lot easier. So that gives me a wholesome answer 0.556, and that's 5.56%. That's the probability of a type 1 error. Let's look at question number 2. It says Jill shoots arrows at a target. Last week, 65% of her shots hit the target. This week, Jill claims that she has improved. So, what I am hypothesizing is that P is now greater than 0.65 out of her first 20 shots. She hits the target with 18 shots. So, that's the test statistic. Assuming shots are independent, test Jill's claim at the 1% significance level. So if you've done hypothesis testing, you would know that whenever you have a test statistic, you borrow the sign from the alternate hypothesis. If you are doing a hypothesis test, you should write all of this down, H0, H1, and then calculate the probability. You're going to say that I'm going to calculate the probability of X greater than or equals to 18, which means I want to calculate the probability of 18, 19, and 20. Again, what I'm going to do is I'm going to write all of these down in terms of 20, in terms of the probability formula. 0.35 power 2, 0.65 power 18 plus 20C19, 0.35 power 1, 0.65 power 19. You've got to write all of this down. That's part of the working. You can't skip over that. What you can skip over is writing down all each individual probability from a calculator. So you could do a collective calculation and get one final answer out of this. So I'm going to again use my calculator to do the calculations for me. So I'm going to say 17, 20, 0.65. I'm getting 0.0121. That's 1.21%. Now, whenever you're concluding, before you conclude, you need to figure out how to reach that conclusion, right? And in the case of a binomial distribution, what you would do is you would compare it to the significance level. So I'm going to compare 1.21% to 1%. It's greater than the significance level, therefore it's not in the rejection region. You fail to reject H0, and essentially what you are doing is you are accepting H0. You will say that there is not enough evidence to say that she has improved. And that's going to be your complete solution for these 5 marks. Remember to always write a comparison between the probability and the significance level so that you reach your conclusion. Question number 3. It says an engineering test consists of 100 multiple choice questions. Each question has 5 suggested answers. Only one of which is correct. Ashok knows nothing about engineering, but he claims that his general knowledge enables him to get more questions correct than just by guessing. So if he was guessing, he would get 1 out of 5 correct answers. And that would be true when he was just guessing, because 1 out of 5 suggested answers, one of them has to be correct. But if he claims that he has more capability than just guessing, he's not just guessing, he has more knowledge, although he hasn't done engineering, I would say that this probability of getting an answer correct should be greater than 1 over 5, given that he has knowledge of given that he has a certain amount of general knowledge. Then he says that then just by guessing, Ashok actually gets 27 correct answers. So that is his test statistic. I'm going to calculate that probability. Use a suitable approximating distribution at the 5% significance level whether his claim is justified. So what I'm going to do is I'm going to try to calculate the probability of this test statistic. I'm going to say that x is greater than or equal to 27, and I want to calculate that probability. A small problem with calculating that probability is that this number is too large for a binomial distribution. I have about 100 trials because there were 100 questions. I can't go on and calculate 28, 29, 30 and so on. So this question is now about binomial to normal approximation. Now remember that I'm not turning this around into test of the population mean. It's still the test of a population proportion. I want to calculate a certain probability, and I'm using the help of a normal distribution to calculate that probability. So what I'm going to do is I'm going to first do my continuity correction, say that this becomes x is greater than 26.5. Then I'm going to calculate NP and NPQ. Let's see, 20 into 0.8 should give me 16. So I'm going to turn this around into z then and say that this is 26.5 minus 20 divided by root of 16. I'm getting 1.625. So 1 minus 5, 1.625. I have to use my normal distribution table for 1.625. Page 224. Let's go to the last page. 1.625. So 1.62 and 5 is 5. So that's 9479. 9479. Let's see, what do I get? I'm getting 0.521. Now 0.521 is basically 5.21%. That's 0.0521. That's 5.21%. That's again greater than the significance level, so you fail to reject each not. There is not enough evidence to suggest that Ashok has superior general knowledge. Okay, that's another question down. Question number 4. It's a long question. We have about how many? 11 marks. Okay, it says at a certain hospital it was found that the probability that a patient did not arrive for an appointment was 0.2. So they missed their appointment at 0.2. The hospital carries out some publicity in the hope that this probability will be reduced. They wish to test whether the publicity has worked. It is suggested that the first 30 appointments on a Monday should be used for the test. Give a reason why this is not an appropriate sample. So there is the bias that only the Monday was used, only Monday was used, and only the first 30 appointments were used. Only first 30. Maybe people in the morning do arrive on time, or people in the morning do not arrive on time. It could be in both those cases. Then it says a suitable sample of 30 appointments is selected and the number of patients that do not arrive is noted. This figure is used to carry out a test at the 5% significance level. So now they've changed the sample. Explain why the test is one tail and state the suitable and null or alternate hypothesis. Okay, so I'm going to first state the null and alternate hypothesis. I'm going to say that 0.2, and since I'm trying to reduce the probability of patients arriving, not arriving, I'm going to say that the alternate hypothesis is H1SP is less than 0.2. It is a one-tailed test because I am testing if the probability has decreased Okay, state what is meant by a type 1 error in this context. So type 1 error is fail to reject H naught while H naught is true. So this hospital concludes that publicity was effective while it wasn't. Was not. That is saying that the probability has decreased while it has not decreased. Then it says use the binomial distribution to find the critical region and find the probability of a type 1 error. So whenever you have this kind of question where you are asked to determine a critical region, that question is about finding out, basically through trial and error, a probability that is less than your given significance level. So the given significance level in this case is 5%. So I'm looking for a number for which the probability of less than or equals to those numbers, because the test statistic is used takes on the sign of the alternate hypothesis. So I'm looking for a number that will give me a probability less than 5%. So I could start trying with any of the numbers. The general idea is to sort of guess a number, a small number or a large number. If you're working with, let's say, 90% probability, you would work with larger numbers. But if you're working with smaller probabilities, 2%, 20%, and so on, I could, let's say, start with, I say that I did a trial on 30 people and 20% was the probability of being late. So let's start with 6 people. Let's find out what the probability of x less than or equals to 6 is. Now this would be a certainly time consuming calculation, because you'll have to calculate all these probabilities: 0, 1, 2, 3, 4, 5 and 6. So the wiser idea is just to take a sufficient number of numbers and say, let's say I calculate up till 3. Let's say I don't go on to 6. If I really have to go up to 6, I'm just going to keep adding numbers to it and then sort of determine if I reach that position. Now I again have to write all these expressions. I'm going to say that this is 30C0 0.8 power 30, 0.2 power 0 plus 30C1 0.8 power 29, 0.2 power 1, 30C2 0.8 power 28, 0.2 power 2, 30C3 0.8 power 27, 0.2 power 3. Okay, what I will do is, again, this calculator makes my life easier. It sums up all those probabilities. It could essentially tell me exactly where I need to calculate up to, but I don't want to go down that road right now. So you can watch the videos regarding the use of a calculator to figure out that. So I'm going to say 3, 20 and 0.2. So this probability comes out as, I'm making sure that I've done this correctly. Oh, n is 30. That gives me 12.27%. So that is more than what I wanted. It's way above 5%. So what I will have to do is I will have to cut this down. So I'm going to try out x is less than or equals to 2. Now if you've done this on a calculator, what you only need to do is just subtract the probability of 3 from that and get your answer. Since my calculator does all of this automatically, I can just punch the numbers on a calculator and get you the final answer. That's 4.42%. That is less than 5%. There's no other number between 2 and 3 that would give me an appropriate probability. So I can say that the critical region starts from 2. Okay, and what was I trying to find? I was trying to find the critical region and the probability of a type 1 error. So the probability of a type 1 error is the probability of the critical region, and that is 4.42%. Moving on, part 5. In fact, 3 patients out of the 30 do not arrive. State the conclusion of the test, explaining your answer. So 3 is in the acceptance region. So you accept H naught or fail to reject H naught. There is not enough evidence to suggest that probability of patients missing appointments has decreased. Okay. Let's move on to question number 5. It says, at the last election, 70% of people in Appalachia supported the president. Luigi believes that the same proportion support the president now. Maria believes that the proportion who support the president now is 35%. So she is hypothesizing that it's decreased rapidly. So H naught is basically P is 0.7, and H1 should then be P is less than 0.7. That is Luigi, and that is Maria. To support the president, in order to test who is right, they agree on a hypothesis test, taking Luigi's belief as the null hypothesis. They will ask six people from Appalachia. So it's a small test chosen at random, if more than 3 people support the president, so they will accept Luigi's belief. So in this case, what they've given you is that they've told you that they're going to accept Luigi's belief. That means they're going to accept H naught when more than 3. So the critical region or the rejection region is then less than or equals to 3. It says calculate the probability of a type 1 error. So type 1 error is finding the critical region. So that is what I've already told you about. So x is less than or equals to 3. So 0, 1, 2, and 3. I am going to ignore the probability from Maria, and I'm going to just write 6C0, 0.3 power 6, 0.7 power 0. I'm not writing all of them right now, but that is how you have to write them. Since I have my calculator, I can quickly do this and take you to the next question. On the exam, you have to show me a certain amount of working. You can't skip all the working, so make sure that you do that. So I am getting 256.256, so 25.6% is the probability of a type 1 error. It's pretty high in this case, partly because they've sort of taken the critical region halfway through the number of the sample, basically. If Maria's belief is true, calculate the probability of a type 2 error. So a type 2 error also always has a new probability. So type 2 error is basically, if you remember from the lecture, it's the probability of the acceptance region using the new parameter. So acceptance region using new P. So I'm going to say that I want to calculate the probability of x greater than or equals to 4 or just greater than 3. whatever you want to write it as. I just want to calculate the probabilities of 4, 5 and 6, but this time I'm going to say that this is 6C for my acceptance would my success would be 0.35 and my failure would be 0.65 because I'm taking the new evidence into account. Okay, let's see. 0.35. So I'm getting 0.117, 1174, which is 117. So that's the probability of a type 2 error. Then it says, in fact, 2 of the 6 people say that they support the president. 2 of the 6 people say that they support the president. So my test statistic is basically 2. Let's see if that is in the critical region or it's not in the critical region. State which error, type 1 or type 2, might be made. So I will have to decide whether I accept H0 or reject H0. That's what I have to include. 2 is in the critical region. Therefore, you reject H0. When you reject H0, you are more likely to make a type 1 error. Type 1 error could have been made that is Maria's claim was accepted while Luigi's was true. So you rejected Luigi's claim while it was true and you accepted Maria's claim. So that they will reject Luigi's belief. That's what the question says as well, although it may be true. So I should rather write that is Luigi's claim was rejected. It's the same thing. It's just you accept or reject it, not you don't really talk about the alternate hypothesis. Okay, moving on to question number 6. It says a cereal manufacturer claims that 25% of cereal packets contain a free gift. So I'm just going to write that down. Low-like suspects that the true proportion is less than 0.25. In order to test the manufacturer's claim at the 5% significance level, she takes a random sample of 20. Find the critical region for the test. So again, this question is about trial and error. So what I'm going to do is I could certainly start off with 4. I could say that x is less than or equals to 4. Let's check. That's a lot of probability to calculate, but I'm still going to go ahead and do that and see what do I get. Maybe I get a very large number, so I'm going to rapidly then decrease it and see what happens. Again, emphasizing on the fact that whenever you have a question that is asking you for the critical region, it's more or less a question on trial and error. So make sure that you understand that properly. And that gives me a very high probability, 41.5%. So I need to rapidly decrease it. So I'm going to make that less than or equals to 2 now. I'm going to cut out 3 and 4. That gives me 0.0913, which is 9.13%. That's still above the significance level. So I'm going to go down again and say that x is less than or equals to 1. And that gives me 2.43%. So inside 5%. So that's the critical region. Then it says, hence find the probability of a type 1 error. So you've already found out that. You're going to say that it's 2.43%. That's why it says hence, and it's just 1 mark. you need to be able to tell me that the critical region is basically the probability of a type 1 error. Lola finds that 2 packets in a sample contain a free gift. So is she in the critical region? No, she's not in the critical region. Not in the critical region. Critical region or rejection region, whatever you want to call it. Therefore, fail to reject H naught. There is not enough evidence to reject the manufacturer's claim. That's what they're claiming, right? Okay, moving on. This says it is not known whether a certain coin is fair or biased. In order to perform a test, Raj tosses the coin 10 times, so n is 10, and counts the number of heads obtained. The probability of obtaining a head on any throw is denoted by P. So the null hypothesis is, it says P is 0.5. Find the acceptance region. Now, since I am just testing whether it's fair or biased, I don't know which of those outcomes, head or tail, will have a higher probability. So in order to be open to both those possibilities, I'm going to say that the alternate hypothesis is P is not equals to 0.5. This is basically a two-tailed test. Now, the probability of obtaining a head on any throw is this. Find the acceptance region for the test, given that the probability of a type 1 error is to be at most 0.1. So the probability of the critical region or the type 1 error is at most 0.1. So I have to find a critical region such that its probability is less than 0.1. Now for the critical region, again, something that I have to do is trial and error. Now with the two-tailed test, what you have to be aware of is that the critical region lies on both sides. Although it's not normal distribution, but I would want to draw that just to explain this to you, that what I'm trying to do is I'm trying to find these two sides, and I'm saying that these two together have to be 10%. Now since the critical region has to be symmetric, what I can then conclude is that one of these will be 5%. That will help me draw up the critical region appropriately, that I could just test one side at once and then the other side, and then just sort of replicate onto the other side. So what I'm going to say that the lower tail should be less than or equals to 0.05%. So in order to do that, I'm again going to start taking numbers. I'm going to say that x is less than or equals to 2, for example. I'm going to say 0, 1 or 2 key probability, and let's see what that comes out as. I'm going to say that the trials are, how many trials were there? It says 10 trials, right? And n is 10. So I'm going to say that n is 10. I'm going to keeping this as 2 and 0.5. This probability comes out as 0.0547. I wanted something less than 5%. So I'm going to reduce that critical region. I'm going to say that this is x is less than or equals to 1. So then what do I get? I get 0.0107, and that is what I wanted. So one-sided critical region is basically x is less than or equals to 1. Now since this critical region has to be on both sides, because this is a two-tailed test, remember that 0, if I were just to list down numbers for you, just to explain to you how I'm determining the other side of the critical region. If I've left out these two numbers as part of the critical region, I should have a similar boundary on the right hand side. So there's going to be this region. This is also the critical region. So the rejection region is therefore x is less than or equals to 1, or x is greater than or equals to 9. X is greater than or equals to 9. So the acceptance region is The opposite of that, the acceptance region, is going to be x is between 2 and 8 and is inclusive of both 2 and 8. That is how you would determine, again, acceptance regions. And critical regions or rejection regions are always determined using your trial and error method. There is no other way of doing that. So that is how you would determine it. Then it says calculate the probability of a type 2 error in this case. So type 2 errors are then simply probabilities of acceptance regions using the new p, that is 0.7. So I'm just going to say that I calculate acceptance region. Acceptance region is from 2, 3, 4, 5, 6, 7, 8. So that's a 8. So that's a lot of probabilities to calculate. Again, even if I do the subtraction method, just by subtracting the remaining probabilities, it's still a lot to do. So I'm going to use my calculator a little intelligently in order to do that. I am first going to calculate the probability of these two. That's come out very small actually. So these two together, 0.0001437, and let me just calculate the entire thing on a calculator quickly rather than pondering over it. So I'm just going to calculate less than 8 and just writing some calculations here. Ideally you should do this your own way, whichever calculator you have. So what I've done is I've calculated the probability of x is less than or equals to 8, and I'm going to subtract 0 and 1 from it so that I get my answer. So what I wrote down before was minus 0.0001437. So 0.8507 minus 0.0001437. Hopefully that gives me the right answer. Yes, 0.850556, which is 0.851. So that is a two-tailed question which a lot of people keep asking me. Yes, two-tailed tests can both appear in normal binomial distributions and Poisson distributions as well. With normal distributions they're relatively easier, but that is something that you also need to know for your test, for your exam. Okay, let's do this question. It says, at an election 2010, 15% of voters in Bradfield voted for the Renewal Party. 1 year later, researchers asked 30 randomly selected voters in Bradfield whether they would vote for the Renewal Party if there were an election next week. 2 of these 30 voters said that they would. So that's the test statistic. Using a binomial distribution, tested the 4% level, that the null hypothesis that there was no change against the alternate hypothesis that there has been a decrease. So probability of x less than or equals to 2, 0, 1, and 2. Let's quickly do that. A relatively simple question. N is 30 and 0.15. 0.1514, that's 15.14%. That is way more than 4% significance. So you accept H naught and you conclude not enough evidence to say that popularity has decreased. Okay, explain why the conclusion in part 1 can involve a type 1 error, because cannot involve a type 1 error because type 1 error occurs when you reject H naught. Errors occur when you reject H naught. Here we haven't rejected H naught. State the circumstances in which the conclusion in part 1 would involve a type 2 error. So this part is a little tricky, and I've never seen a question like this when I was solving this for the first time. It may have skipped my although it's an older question. So type 2 errors, for type 2 errors, there's generally additional information in terms of that there's new evidence that P has actually decreased, and you sort of have that. So state the circumstances. So what circumstances would be there? That the probability or the popularity basically, which was 15% before, has actually decreased. So that is what this answer is also saying, that new evidence that P is less than 0.15. So that should be your final answer for this 1 mark question. So that is the first part of this marathon. Hopefully you were able to follow with me in the questions. I would strongly encourage you to go back, pause the video at certain instances, and try to redo the questions so that you understand exactly what's going on. Please make sure to like, subscribe for future videos. Thank you.